Okay, hello guys. This is section 6.6, logarithmic and exponential equations. Okay, and let's just start it with logarithmic equations. So we're going to start first with logarithmic equations. So what we're going to do in this section, we're going to solve more logarithmic equation and exponential equations. So we're going to start with logarithmic equations. And there are two ways to solve them. The first one is change logarithmic equation to exponential. And how you're going to do it, you will use just definition of log. Y it's equal logarithm of base a of x is equivalent. This statement is equivalent that x is the same as base, which is a to the power of y. Okay, so x is the same as a to the power of y. And of course, base has to be positive, and the base of exponent and base of log can't be 1. So let me give you one example. Logarithm of base 2 of 1 minus 2x equal 3. So what we're going to do, we're going to change that to exponential. That means that means that 1 minus 2x, it's the same as 2 to the third power. Okay, and you will solve for x, and you will end up with x equal negative 7 over 2. A couple things about when you're solving logarithmic equations, that you always want to find the domain first. Because domain will be expression next to log, which is 1 minus 2x. It has to be greater than 0. So let's subtract 1 from both sides. We're getting negative 2x, it's greater than negative 1, and divide each by negative 2, and you're getting x is less than 1/2, which means domain is from negative infinity to 1/2. Why this is important? Because when you find the domain and you're solving logarithmic equation, I talked about it in previous lectures, you sometimes have extraneous solutions, which are fake solutions. So you need to check if negative 7 over 2 is inside of the domain, which definitely yes. Okay, so we always find the domain to avoid the extraneous solutions. Extraneous solutions are the fake solutions. So this is one of the example how to change logarithmic equation to exponential. And the second way of solving logarithmic equation is to use one-to-one property. One-to-one property, since logarithmic equation is one-to-one function. What that means, if you have two logarithms, logarithm of base a of m, and you have logarithm of base a of n, mn expressions, and if you see that they both have logs on both sides, and the most important that the bases are equal, you can just ignore them, and this statement is equivalent to that m is equal n. So if log of base a of m is the same as log of base a of n, that means m has to be equal n. Let me give you an example. 2 log of base 5 of x is equal log base 5 of 9. Okay, so first what I'm going to do, I'm going to find the domain. So domain of logs, its expression next to log always has to be positive. So the domain is from 0 to positive infinity. Now, I want to use that one-to-one property, but note will be before you use one-to-one property, you have to isolate logs, okay? So to use one-to-one property, you should not have any coefficients in front of log. You can't have any coefficients in front of the logarithm. Logarithms. So in this case, I should not have 2 in front of the log. So you guys learn properties, okay? We should move that 2 back to x, okay? We're going to use that power property. Apply the power property. 2 logs base 5 of x is equivalent to log base 5 of x squared. So I hope you guys remember that when we had that power, we'll move the power in front of log, or you can put it back. Equal log base 5 of 9. Now when you clear the coefficients which were in front of logs, we are ready to use one-to-one property. So now use one-to-one property. And look what happened. We have logs on both sides. The most important that they have the same basis. So what that means? That means that x squared has to be equal to 9. And now you just solve the equation for x. So we're going to take the square root of both sides, and we end up that x is equal to 3, x equal negative 3. Now, when you have two solutions, you always have to check, okay, if they both are solutions or maybe one of them is extraneous. So look what happened. The domain are all the x's greater than 0, which is from 0 to positive infinity, which means x equal 3 is the solution. However, x equal negative 3, it's not the solution. This is the extraneous solution, which means you ignore it. So ignore it. So that's that fake solution, okay? You can get it algebraically, however, it doesn't make sense. Okay, we're going to practice more. So I picked a couple problems from your textbook. Next, which I want to do with you guys, it's number 21 from page 465. So we need to solve logarithmic equations. We have log base 2 of x plus 7 plus log base 2 of x plus 8 equal 1. So you see logs, first thing what we're going to do, find the domain. And always do that for logs, okay? Because many times you end up with extraneous solution. What that means, the expression next to log, which is x plus 7 and x plus 8, has to be positive. So x plus 7 has to be greater than 0, and x plus 8 has to be greater than 0. That means x is greater than negative 7, and x is greater than negative 8. So let's graph both of them together. In orange will be this, that x is greater than negative 7. This is negative 7. X has to be greater, so I'm shading everything to the right side. Okay. In red will be x is greater than negative 8. So this is negative 8. X has to be greater to negative 8. So I'm moving all the way right here. So the solution of those two inequalities, the answer will be, because you have and we talk about it, and means intersection, is the intersection of both. Of both graphs. Okay, so intersection of both graphs will be right here, from negative 7 to positive infinity. From negative 7 to positive infinity. So this is our domain. That's the intersection of both. So again, don't forget that we're talking about domain. So any x is greater than negative 7 will satisfy our equation. Okay, so we have a domain. Now look what we have to do. Okay, first of all, what you need to do, you need to condense that. You need to simplify that. So hopefully you guys remember that when you have a plus and you have two logs, this is the product property. The sum of logs is equal log of product. So we're going to rewrite that under one log, log of base 2, and product of x plus 7 times x plus 8 equal 1. And how you want to solve it? I'm going to change that to exponential. This is how I'm going to solve it. Solve by changing to exponential. Okay, so base of my log 2 to the power of 1 has to be equal to x plus 7 times x plus 8. So let me just rewrite. X plus 7 times x plus 8, it's equal to 2 to the power of 1, which is 2. So I changed logarithmic equation to exponential since they are inverses, okay? So this is equivalent. So now what you're going to do, okay, here we need to FOIL. So we have x times x, which is x squared, x times 8, 8x, 7 times x is 7x, 7 times 8, we're getting 56, equal to. So like you guys see, it's quadratic equation, so we're going to move everything to the left side. So I'm going to subtract 2 from both sides, and we have x squared plus 15x plus 54 equals 0. And now we're going to solve quadratic equation. Solve quadratic equation. Okay, most of the quadratic equation in our textbook you can FOIL. So find a is equal 1, b is equal 15, c is equal 54. So we're looking for two numbers which by multiplication will give you a times c. So a times c is 54. And the same two integers by addition should give you b. And in our case, b is equal 15. Okay, so what's going to work? 9 and 6. 9 times 6 is equal 54. 9 plus 6, we're getting 15. So when we find those integers, we're creating two factors, x plus first integer, which is x plus 9, times x plus second integer, which will be x plus 6, equals 0. And now we're using zero product property, which means when the product is equal 0, that means one of the factors or both of them are 0, which is x plus 9 is equal to 0, or x plus 6 is equal to 0. We're solving for x. We got x equal negative 9, x equal negative 6. Okay, so two solutions, which one is correct? So now you're going back to the domain, okay? So don't forget that the domain is all the x's from negative 7 to positive infinity. What that means, x equal negative 9, it's extraneous, okay? Negative 9 does not belongs to that interval. So this is extraneous. X equal negative 6 definitely belongs to that interval. So we have one solution. Okay, so the solution set is x equal negative 6. Okay, so we have one solution. Again, the one in red is a fake solution, extraneous solution. So I know it's extra step to find that domain, but I recommend it to find that domain at the beginning, because when you end up with those two solutions, most likely one of them you have to leave it and ignore it, okay, which will be extraneous solution. Okay, so this is what happened. Look what happened. Again, we apply everything here. We had logarithmic equation. We changed that logarithmic equation to exponential. And then we end up with quadratic equation. Okay, so everything what you guys learning in this class apply. So it's very important that we not forgetting what we learned, but we keep applying. Let's do 31. So I pick problem 31, also from your textbook, from the same page. And here the equation looks that way. You have logarithm of base a, they were not specific, so just a, x minus 1, we know the base it's always positive, minus logarithm of the same base of x plus 6, it's equal logarithm of base a of x minus 2, minus logarithm of base a of x plus 3. So all those expressions next to log, you guys cannot separate them, okay? They are together. So first what I'm going to do, find the domain. Because we don't want to have those extraneous solutions. So how you find the domain? You take the expression next to log and you solve inequality. X minus 1 has to be greater than 0, and x plus 6 has to be greater than 0, and x minus 2 has to be greater than 0, and x plus 3 has to be positive. So I'm giving the condition. I would be able to solve the equation if those conditions are satisfied. So solve each inequality. You will end up with x greater than 1. Here, x greater than negative 6, x greater than 2, x greater than negative 3. And when you guys solving inequalities, means that you need to graph them together and find the intersection. And means intersection in algebra, but also in probabilities. Okay, so I'm going to graph all of them together on number line. Okay, that will be in green, x greater than 1. So I'm shading everything to the right of 1. In orange will be x greater than negative 6. So I'm shading everything. In red will be x greater than 2. try it and use, let's just pick purple. In purple will be x greater than -3. So the solution is where all four colors intersect. So like you guys see, the intersection will be x is greater than 2. That's the solution. That's the intersection. Okay, here, intersection. Okay, so the domain are x is greater than 2. You can leave it that way, or you can have an interval notation. We just need to have that to figure out which solutions are fake solutions. Okay, so now we're going back. So when we have the domain, now this is what we're going to do here. On the left side, let's go back, you have a difference. Difference means quotient. Okay, so we will need to use quotient property. So you guys should have those properties in one place. Hopefully you have them already in the index card. The difference of logs means log of a quotient. So the left side I'm going to rewrite as logarithm of base a, and I'm taking quotient. So it's going to be x minus 1 over x plus 6. Okay, equal. On the right side, you're also going to apply the quotient property because we have that difference. Difference of logs equal log of quotient. So I'm going to rewrite this as log of base a and quotient of x minus 2 and x plus 3. Now look what happened. You have log of base a on the left side, log of base a on the right side. What that means, you can ignore them. We're ready to use one-to-one property. One-to-one property means you can ignore this. It's not like a canceling, but we can ignore it since they both have log of the same base in front. The entire expression, that means that x minus 1 over x plus 6 is the same as x minus 2 over x plus 3. Okay, so you have fraction equal fraction. The way I recommended to solve it, use cross multiplication. I think that will be the easiest way. So we multiply across. X minus 1 times x plus 3 needs to be the same as x plus 6 times x minus 2. So we use cross multiplication. Next, what we're going to do, FOIL the left side and FOIL the right side. So we're going to FOIL the left side and we're going to FOIL the right side. So we have x times x, x squared, x times 3, it's 3x, negative 1 times x is negative x, and negative 1 times 3 will give you negative 3, equal. FOIL the right side, x times x, we're getting x squared, x times negative 2, it's negative 2x, 6 times x is 6x, and 6 times negative 2, it's negative 12. Simplify, so you're getting x squared plus 2x minus 3, it's equal x squared plus 4x minus 12. Okay, look what happened. You have x squared on the left side and x squared on the right side. Okay, if you will try to bring them together on one side, that will cancel, so you can cross it out. So now we have 2x minus 3, it's equal 4x minus 12. Let's bring x's to the left side. So I'm subtracting 4x from both sides. We're getting negative 2x minus 3, it's equal negative 12. I'm adding 3 to both sides. and we end up with negative 2x, it's equal negative 9, and divide each by negative 2. And we have x, it's equal 9 over 2, which is 4.5. Let me check if this is correct solution. So let's go back to the domain. So our solution has to be in the domain. Domain our x is greater than 2. So definitely x equal 9 over 2 belongs to that domain. So we good. So the solution set is 9 over 2. X equal 9 over 2. We don't have extraneous solution here. Okay. One more. No, I mean, that's it from logarithmic equation. Next, what I want to do, I want to talk about solving exponential equations. Okay, so second part of the lesson is solving exponential equations. Okay, and also there's two ways to solve them. The easy one, the first one will be use one-to-one property. So that means if you have base to the power of u, it's equal base to the exponent v. This is equivalent that u is equal v. Okay, don't forget that bases are always positive. Okay, so that's one-to-one property. Example will be 4 to the power of x. It's equal 4 to a second power. Since we have the same basis, this is the same as x equal 2. So the exponents needs to be equal. That's how one-to-one property works. And the second, so that was the first one. The second method is change exponential expression to logarithmic equation expression by attaching log to both sides. Let me write note. Choose the base of log the same as the base of the exponential expression. Okay, so let me show you. And also in red, note, isolate okay, you know what, not note. It will come back. I was trying to add something, but I forgot. Okay, let me give you the example. Okay, 2 to the power of x, it's equal 5. So we're going to change that to logarithmic equation. So what we're going to do, attach log, and don't forget that logarithm equations have the same basis as exponential equations. So log of base 2 to both sides. So I'm attaching log of base 2 to both sides equal log base 2 of 5. Why are we doing that? Because you guys learned so many properties of log. So look what happened. Base of log is the same as base of the exponent, so they canceling each other, and we will end up only with x equal log of base 2 of 5. So this is what we're going to do. Of course, later you can always plug in that into the calculator, okay? So don't forget that to evaluate this on calculator, you're going to use change of base formula. So change of base formula, you can use ln on common log. I usually use ln. Log base 2 of 5, you can evaluate that as ln of 5 over ln of old base, which is 2. Okay, so this is what we're doing on calculator. Okay, let's practice. So let's practice. For practice, I pick couple examples, couple problems from your textbook. This is page 465, number 43. Let's solve those exponential equations. And when I will be solving those equations, I will be giving you more hints because again, each example require some of them, most of them have the same steps, but sometimes we need to apply some extra. So here, what they want you to do, they want you to solve the equation and round up the answer to 3 decimal places. Okay, so 2 to the power of x, it's equal 10. What we need to do, we need to change that to logarithmic equation. So we're going to attach log of base 2 to both sides because base of exponent it's 2 to both sides. Okay, so log of base 2 of 2 to the power of x, it's equal log base 2 of 10. Here we're going to use the property that the base of log is the same as the base of exponential expression. They cancel each other and we end up with x equal log base 2 of 10. And this is already a nice solution, but when they want you to estimate the solution, you will need to use your calculator. So I'm going to apply change of base formula. This is equivalent, this moment, this is equal to ln of 10 divided by ln of old base. And you guys will plug that into the calculator, practice that. You should end up with 3.322 because I'm rounding up the answer to 3 decimal numbers, decimal places. Okay, so you have to, again, if you want to do it in one shot, okay, on your calculator, I will open parenthesis, I will type ln, parenthesis will open, you will type 10, close parenthesis, do the type, click on the division, open parenthesis, type ln, parenthesis will open, you put 2, close parenthesis, and click enter or equal sign. And you should get that solution. Okay, so that's not bad. Let's do more. This is number 53. from page 465. So let's practice this. We have 1.2 to the power of x. It's equal 0.5 to the power of negative x. So be careful here. You cannot use one-to-one property because, again, we have different bases. Okay, so first of all, what I see negative exponent. Okay, so this is negative exponent. So hope you guys remember the rule that x to the power of negative n is the same as 1 over x to the power of n. So that's what happens when you have negative exponent. So we're going to rewrite that as 1 over 0.5 to the power of x. 0.5, again, 0.5 is the same as 5 over 10, which is 1/2, right? So 1 over 1/2 is the same as 1 times 2 over 1, which is just 2. So let's simplify that. This is 1.2 to the power of x. It's equal to the power of x. Class, and I want you to always think, okay, you have an equal sign. That means left side has to be equal to the right side. When that's going to be possible? Bases are different. So the only way that this equation is satisfied, it only works when x is equal to 0. Okay, so I'm not going to solve more because look what happened. And this is the solution. Let's check. Okay, so sometimes we really don't need to go farther. We should be able to see it. Okay, when they are equal, for which x the left side and right side are equal? Only when x is equal to 0. Check x equals 0. So you're getting 1.2 to the power of 0. It's equal to 2 to the power of 0. So that's, we're getting here 1 equal to 1, which is correct. Okay, for other x's, it's not going to work. Okay, so I'm going to stop. X equals 0 is our solution. Okay, and I want to go back to, which problem was that? 53. I want to go back a little bit and solve number 50 from the same page. So logarithmic equation, exponential equation, they are a little different. Sometimes at the beginning students struggle because it's a little different method of solving them. Okay, we're changing them to inverse functions. But if you struggle and you need hints or tips, again, I really want you to send me a picture of the problem which you work on it, and I will be more than happy to give you the hints and step by step how you can solve it. So 2 to the power of x plus 1 equal 5 to the power of 1 minus 2x. Okay, so a couple things about this equation. You have exponential equation, you want to change to logarithmic equation. So we want to change to logarithmic equation. So I teach you guys. So what you're going to do, you're going to attach log. Okay, log of which base? When the bases are different, look, on the right side, your exponent has a base 2. On the left side, the exponent has base 2. On the right side, the exponent has base 5. So when your exponential expressions have a different basis, I recommend to attach ln. So attach ln, which is the base of ln, it's e, to both sides, because our exponential expressions have different bases. Like you see, we have base of 2, base of 5. I don't want you to pick, okay, let me go with base 2 or let me go with base 5. If that's the case, we attaching ln to both sides. Okay, so I'm going to attach ln to both sides. I have ln of 2 to the power of x plus 1 is equal to ln of 5 to the power of 1 minus 2x. Okay, next what you're going to do here, okay? Next, we're going to apply power property. Okay, you have power, so you're going to move in front of ln. You have power, you're going to move in front of ln. So next, use power property. We're going to move that exponent in front of ln. So it's going to be x plus 1 times ln of 2 equal 1 minus 2x times ln of 5. Okay. We need to solve for x, so don't forget that we need to solve for x. Okay. Before we start moving stuff around, I want you to distribute. So we're going to distribute. So this is the same as x times ln of 2 plus 1 times ln of 2. Okay, so don't forget that when you multiply expression by log, you're putting that as a coefficient of log. Equal, here we're also going to distribute. This is 1 times ln of 5 minus 2x times ln of 5. Okay, let's simplify that a little bit. So x ln of 2 plus 1 times ln of 2 is just ln of 2 equal 1 times ln of 5 is just ln of 5 minus 2x ln of 5. Okay, this is better. May not look nice, but it's better. What you're going to do next, move expressions with x to the left side. And the rest keep on the right side. Okay, so I want to move negative 2x ln to the left side. So I'm going to add 2x ln of 5 to the right side, to the left side. Okay, so again, I keep that as a one expression. So we'll end up with x ln of 2 plus 2x ln of 5 plus ln of 2 equal ln of 5. Okay, so the idea is to isolate x. Now we're moving ln of 2 to the right side, so let's subtract ln of 2 from both sides. Again, they are just real numbers, okay? But they are nasty because have infinitely numbers after decimal. That's why it's better to keep them as a ln of 2. This one will cancel, and we end up with x ln of 2 plus 2x ln of 5 equal ln of 5 minus ln of 2. Okay? Next, what we're going to do on the left side, look what happened. You have x and you have x. So I want you to factor out x. So we have x times, in parentheses, ln of 2 plus 2 ln of 5 equal ln of 5 minus ln of 2. Okay, and the last step will be divide all by expression ln of 2 plus 2 ln of 5. Cancel, and we have x equal ln of 5 minus ln of 2 over ln of 2 plus 2 ln of 5. Since they want you to estimate the solution, so you guys can plug it in that way in a calculator. That will give you about 0.234. I just want to let you know that you could rewrite this. We could simplify that better. We can do more because we can apply more properties. So first of all, you have a quotient. So the numerator can be rewrite as ln of 5 over 2. Okay. Now in denominator, you can apply the power property. So you can move that 2 back to 5. And you can rewrite this as ln of 2 plus ln of 5 to a second power, which is ln 5 divided by 2, this is just 2.5, over ln of 2 plus ln of 25, because 5 to a second power is 25. And we can simplify that better as ln of 2.5 over, hopefully we remember, sum of logs is equal log of product. So we can rewrite this as ln of 2 times 25. Again, this is 2 times 25. So ln of 2.5 over ln of 50. For me, that will be easier to plug in a calculator. But if you will get here, you should be able to get that solution. So a lot of properties, but again, I'm very satisfied with this answer. And you have quotient of logs. There's no property of quotient of logs. It's a difference of log. It's equal log to a quotient. But this is something, ln of 2.5 over ln of 50, what can be simplified. I'm going to stop because the lecture is already 47 minutes and the longer lecture is harder for me to download on YouTube. However, it's going to be probably 10 more minutes of the second video. I just want to show you how to solve exponential equation quadratic in form. Okay, so that will be video 1. You guys have a lot of information. I still need about 10 more minutes to cover fully this this lesson. Again, this is mathematics. I can keep talking, but the most important, can give you examples and solving them that you guys practice. Okay, practice on your own. And again, when I'm teaching these sections with logs and exponents 1-to-1, usually I notice that sometimes students struggle with that. So again, be honest with me. You're solving problems, there's a lot of practice, you struggle with them, let me know. Don't be afraid to send me a message, okay? Especially right now, you don't have me in front of you, okay? I will be happy to help. Okay, guys? So I will see you soon with the video 2 of section 6.6. Thank you for watching. Stop recording.